Hello students. So today I am doing class for class 10. The topic is ratio and proportion. So in the last online class also we were doing the same topic, that is ratio and proportion. So let us work out exercise 5.3, page number 98. So in the last online class we did question number 9. So now today we will do question number 10, number 1. So the question is, if a square upon b plus c is equal to b square upon c plus a is equal to c square upon a plus b is equal to 1, let us show that 1 upon 1 plus a plus 1 upon 1 plus b plus 1 upon 1 plus c is equal to 1. That means you have to prove this from given, you have to prove left hand side is equal to 1. Okay, so let us write down given part here. So what is given here now? Here given is a square upon b plus c is equal to b square upon c plus a is equal to c square upon a plus b is equal to 1. That means first is equal to second is equal to third is equal to fourth. That is the last one, 1. So here let us equate first and last, that is first and fourth, to get the value for a square by cross multiplication. That is, if we equate first with last, so by cross multiplication, what do we get? A square is equal to b plus c. Or hiding this second and third, so by cross multiplication, what do we get? A square is equal to b plus c. Again, equating second with last, and by cross multiplication, what do we get? B square is equal to c plus a. Suppose this is number 1 and this is number 2. Again, equating third with last, and by cross multiplication, again what do we get? C square is equal to a plus b. That is equation number 3. That means we get the values of a square, b square and c square. Now let us prove this left hand side is equal to 1. So let us write left hand side. So what is left hand side here now? So LHS is equal to 1 upon 1 plus a plus 1 upon 1 plus b plus 1 upon 1 plus c. Okay. Now since in number 1, 2 and 3 respectively, we know the values of a square, b square and c square. Now you should make this a square. That means you have to multiply 1 plus a by a. If you multiply the denominator by a, you should multiply the numerator by a also, isn't it? That means for the first term, you multiply both numerator and the denominator by a, right? So that is, what do we get? A upon a into 1 plus a, right? Plus similarly, in order to get this b as b square, you multiply both the numerator and the denominator by b. So it is b upon b into 1 plus b plus, what is the last term there? Multiplying numerator and the denominator by c. So what do we get? C upon c into 1 plus c. Clear? So is equal to, this is a upon a plus a square plus b upon, this is b plus b square plus, so what is the last term here? It is c upon c plus c square. So I think you have understood it. So now next, you can put the values of a square, b square and c square from 1, 2 and 3 respectively, isn't it? So is equal to a upon a plus, what is the value for a square? It is b plus c. It is b plus c plus b upon b plus, what is b square? It is c plus a plus c upon c plus, what is the value for c square? What is the value for c square? It is a plus b, right? So let us write here a plus b. Actually, all these expressions are equal, isn't it? And that is a plus b plus c. This is also a plus b plus c. This is also a plus b plus c, right? So let us find out the LCM now. So what's the LCM out here? So all these expressions are same. That is a plus b plus c. So what's the LCM out here? This is a plus b plus c. So this is the LCM. Okay. Now this LCM is divided by a plus b plus c. That means we get 1. So 1 should be multiplied by the numerator, that is e, plus. Again this LCM is divided by the next factor, that is b plus c plus a. That is also 1. And this one should be multiplied by the numerator. So 1 into b is b, plus. Again this LCM is divided by the denominator c plus a plus b, that is also 1. And that one should be multiplied by c, that is 1 into c is c. Okay. So we can cancel these two. That means it is divided, a plus b plus c divided by a plus b plus c is equal to what? 1. So it is proved. So I think you have understood it. So this is very important question. So now we'll do the next question. So you can copy it. So now we'll do the next question, that is 2 of question number 10. So if x square is to by plus cz is equal to y square is to cz plus ax is equal to z square is to ax plus by is equal to 1, let us prove that a upon a plus x plus b upon b plus y plus c upon c plus z is equal to 1. So in this case also we can use the same method as we have done in problem number 1 of 10, right? So here also the given part is there, and but it is given in terms of ratio, but that ratio should be converted into fraction. You can convert that ratio into fraction, right? So here the given is, so let us write down that ratio in terms of fraction. That is x square upon by plus cz, first ratio is equal to y square divided by cz plus ax is equal to z square divided by ax plus by, which is equal to 1, right? So now in this case, let us equate first and last to get the value for x square. You can get the value for x square here by cross multiplication. That means we can equate x square upon by plus cz is equal to 1. Then by cross multiplication you can get the value for x square, isn't it? That is equating first and last. What do we get? X square is equal to by plus cz. Suppose this is number 1. Similarly, by hiding this first and third, you can equate second with last. And then cross multiplication, what do we get? Therefore, y square is equal to cz plus ax. This is number 2. Again, equating third and last. That is, third is equal to fourth. And by cross multiplication, what do we get? That is, z square is equal to ax plus by. Suppose this is number 3. So now you will prove that this left hand side is equal to 1. So let us write left hand side now. So LHS is equal to, what is LHS here? A upon a plus x, right? Plus b upon b plus y plus c upon c plus z. Okay? So now in number 1, 2 and 3 we know the values of x square, y square and z square. So you have to make it x square. So in order to make this x square, you have to multiply it by x. So you have to multiply the denominator by x. If you multiply the denominator by x, you have to multiply the numerator by also x. If you multiply this denominator by x, you have to multiply numerator by x also. Okay? So you multiply both numerator and the denominator by x. So what do we get? Ax divided by x into a plus x. Plus similarly, in order to get this y square, you have to multiply both numerator and the denominator by y. So what do we get? By divided by y into b plus y. Plus, what is the last one? You have to multiply both numerator and the denominator by z to get this z square, so that you can put the value for z square is equal to ax plus by. So write down It is Cz divided by Z within bracket. It is C plus Z. Right? So which is equal to Ax divided by, let us multiply them, Ax plus x square plus by divided by, now multiply by y here, it is by plus y square plus, so what is the third term? It is Cz divided by Cz plus Z square. So I think you have understood it. Now you can put the values of x square, y square and z square from 1, 2 and 3. So let us put the value ax divided by ax plus, what is the value for x square? It is by plus cz. It is by plus cz plus by divided by by plus, what is y square? It is ax plus by. It is ax plus by plus Cz divided by Cz plus, similarly what is Z square? What is Z square here? Ax plus by. It is Ax plus by. So is that clear to all of you? So I think you have understood it. Now these denominators are same expression, isn't it? And so Ax plus by plus Cz, this is also Ax plus by. And so what is y square? It is Cz plus Ax, sorry. This y square is what? So y square is actually Cz plus Ax. This is Cz plus Ax. Okay? Now, for the first term, it is Ax plus by plus Cz. This is also Ax plus by plus Cz. That one is also Ax plus by plus Cz. That means we are getting the same expression in the denominator. So you can easily get the LCM. You can easily get the LCM of these three expressions, first, second and third. So what is the LCM? The LCM is Ax plus by plus Cz. You have to write or Ax plus by plus Cz. Okay? Now this is the LCM of these three expressions. So these three expressions are same. So we write here Ax plus by plus Cz. That is the LCM. Now this LCM is divided by the first term, that is Ax plus by plus Cz. That means it is 1. So 1 into Ax plus again this LCM. This LCM is divided by this same expression Ax plus by plus Cz. That means it is 1. So 1 into by is always by. Right? Then plus. Again this LCM is divided by this third expression, that is Cz plus Ax plus by. These are the same expression, you can cancel them, you will get 1. So 1 into Cz is Cz. So you can write here is equal to, okay. So these are the same expression, you can cancel it. So this is 1 by 1 which is equal to 1. That is proved. So which is equal to right hand side. Okay. So you can copy it. We'll do the next question now. So now let's do question number 11.1. So what is given here? If x upon xa plus yb plus zc is equal to y upon ya plus zb plus xc is equal to z upon za plus xb plus yc, and it is given that x plus y plus z not equal to 0. Let us show that each ratio is equal to 1 upon a plus b plus c. So from the given part, you have to prove that this each ratio is equal to 1 upon a plus b plus c. So in this case, we can use addendo. So what is addendo out here? You can write down that by addendo, each ratio is equal to, you can add those numerators and you can add those denominators by addendo. Okay, so let us write down given here. What is given now? X upon xa plus yb plus zc, that is first ratio is equal to y upon YA plus ZB plus XC is equal to, it is Z upon ZA plus XB plus YC. So this is given, right? So by addendo, what can you write? So by addendo, these, each ratio is equal to, so you can add the expression in the numerators. You can add those numerators, that means x plus y plus z, this divided by, add these denominators, add all the expressions which are in the denominators, right? So it is xa plus yb plus zc plus next ya plus zb plus xc plus next plus, what is the third term? It is ZA plus XB plus YC. I think you have understood it. We are adding the numerators and we are adding the denominators. So now let us simplify it. Is equal to x plus y plus z, this whole divided by. So now here, let us factorize the expression in the denominator. Okay. So xa plus ya plus za, what is common here? It is a, isn't it? So a is taken common, within bracket we have x plus y plus z, right? Again from this yb plus zb plus xb, yb plus zb plus xb, what is common here? Again b is common out here. So what do we get within bracket? Y plus z plus x, that is y plus z plus x, right? And from these unmarked terms, zc, xc and yc are there. What is common here? Plus c is taken common. So within bracket, what do we get? Z plus x plus y. It is z plus x plus y. So actually, within bracket, these are the same expressions, right? So this is x plus y plus z. This is also x plus y plus z. This is also x plus y plus z. That means you can take common here. So let us write down, which is equal to x plus y plus z divided by, what is common out here? It is x plus y plus z. So it is x plus y plus z is taken common out here. So write down the remaining terms in the other bracket. That is, what are the remaining terms here? A plus b plus c. So it is a plus b plus c. So you can cancel this common term out here. This is 1, right? So which is equal to 1 upon, it is a plus b plus c. That means we have proved that each ratio is equal to 1 upon a plus b plus c. That is proved. Understood now? So you can copy it. We'll do the next question now. Now we'll do the next question, that is element number 2. If x square minus yz upon a is equal to y square minus zx upon b is equal to z square minus xy whole upon c, then let us prove that a plus b plus c into x plus y plus z is equal to ax plus by plus cz. So from given, you have to prove this LHS is equal to RHS. Okay. So let us write down given. Given, what is given here? It is x square minus yz upon a is equal to y square minus zx upon b is equal to, it is z square minus xy upon c is equal to k. Let us assume k method here. Okay. So it is suppose. Oh, sorry. In this case, since you have to get the value for k, or since you have to get the value for a, b and c, let us invert it. So by invertendo, you can invert them, isn't it? So by invertendo, we can invert all these fractions. So by invertendo, so what do we get? A upon x square minus yz is equal to b upon y square minus zx is equal to c upon z square minus xy, right? So let us invert all the sides. That is, denominator goes up in the numerator and numerator goes to the denominator, right? So that we can get the values of individual values of a, b and c. Let us assume it as k, suppose. So is equal to k, suppose. Now, first is equal to second is equal to third is equal to fourth. That means equating first and last, that is a upon x square minus yz is equal to k, and by cross multiplication you can get the value for a, isn't it? So therefore a is equal to k into this is x square minus yz. Suppose this is number 1, right? And similarly, by equating this second with last and by cross multiplication, what is the value for b? b is equal to k within bracket y square minus zx. So this is your number 2. And similarly, by equating this third with last and by cross multiplication, what do we get? We can get the value of c, that is c is equal to k within bracket. This is z square minus xy. So suppose this is number 3. Is that clear now? So from 1, 2 and 3 we can get those values of a, b and c, and using these values of a, b and c we can easily prove that LHS is equal to RHS. Okay? So let us write here LHS. So what is LHS now? What is LHS here? It is a plus b plus c into x plus y plus z. So let us put the values now. So is equal to, what is the value for a? It is k into, what is k into? It is x square minus yz, x square minus yz plus, what is the value for b? K into y square minus zx, right? Right. So we'll write here k into y square minus zx, right? Then again, what is the value for c? K into z square minus xy plus k into z square minus xy. So here second bracket is closed into, since there is no space out there, we will write down the second factor in the next step. That is, actually this is the continuation part. This is x plus y plus z. Is that clear to all of you? So now let us simplify it. Is equal to, so now this throughout the term, from the first factor, what is common out there? It is k. So it is x square minus yz plus y square minus zx plus, next it is z square minus xy. Bracket is closed. Again there is no space there into, let us write down the second factor in the next step, that is x plus y plus z. Actually this is the continuation part. Okay. Next. So now let us multiply these two factors. Okay. So is equal to k. Actually there is a formula. If you can remember the formula, you write down the formula. You don't have to multiply them. Okay, so there is a formula. So I'll tell you the formula now. The formula is x plus y plus z into, so let us write down this factor first, x plus y plus z, then the other factor is x square plus y square plus z square minus, this is xy, let us write xy first, this is xy, then minus yz, then write down minus zx. So its bracket is closed, right? So is equal to k. And so now look at the blackboard. The first factor is x plus y plus z, and what is the second factor? It is x square plus y square plus z square. This will be minus xy minus yz minus zx. There is a formula for these two factors. Okay. So if you multiply them, you will get x cube plus y cube plus z cube minus 3xyz. So this is the formula. So this is the formula for what? X plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. So directly for these two factors you can write down x cube plus y cube plus z cube minus 3xyz. Otherwise, if you multiply these two factors, you can take it. You know how to multiply them, isn't it? If you multiply these two factors, so the result will be x cube plus y cube plus z cube minus 3xyz. That is, the product will be x cube plus y cube plus z cube minus 3xyz. So you can remember it as a formula also. Is that clear now? So now, right hand side. What is right hand side here? What is RHS here now? It is AX plus BY plus CZ, which is equal to, so now in the previous steps, we know the formula, we know the value for A, B and C, isn't it? What was the value for A? K into x square minus yz into x, x is there. What was the value for B? K into y square minus zx into y. Next, plus, what was C now? What was C? C was k into z square minus xy and z is there. Okay? Is that clear now? So let us simplify it. What is common throughout the term? It is k is common within second bracket. X square minus yz into x plus y square minus zx into y plus k is taken common outside, z square minus xy into z. So this is the factor within second bracket if k is taken common out here. Okay, so let us simplify it now. So now, which is equal to k within bracket. Let us multiply them. X into x square, x cube minus x into yz minus xyz, right? Again plus y into y square plus y cube minus, it is xyz, right? Again there is no space out there. So let us write it in the next step, that is plus z square into z is z cube plus z cube minus, it is xyz minus xyz, right? So now again you can simplify it further, is equal to k, there is only one term there, x cube plus y cube plus z cube, x cube plus y cube plus z cube, and what is minus xyz, minus xyz, minus xyz, same sign you have to add them, so it is minus 3xyz, so it is minus 3xyz. So are you getting the same expression out here? Yes, this is k into x cube plus y cube plus z cube minus 3xyz. On the left hand side also it is k into x cube plus y cube plus z cube minus 3xyz. That means we have proved that LHS is equal to RHS. So therefore LHS is equal to what? RHS. So that is proved. So I think you have understood it. In this case you have to remember this formula, that is x cube plus y cube plus z cube minus 3xyz is equal to, what is the formula? X plus y plus z into x square plus y square plus z square minus xy minus yz minus zx, or vice versa, that is x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx is equal to what? X cube plus y cube plus z cube minus 3xyz. So that is the formula that you should remember. Okay, so you can copy it. We'll do the next question now. Now, let's do the next question, that is 11 number 3. If a upon y plus z is equal to b upon z plus x is equal to c upon x plus y, then prove that a into b minus c divided by y square minus z square is equal to b into c minus a whole divided by z square minus x square is equal to, the last one is c into a minus b divided by x square minus y square. So this is the given part. From given you have to prove this result. Okay. So let us write down the given part. That is, here given is a upon y plus z is equal to b upon z plus x is equal to c upon x plus y is equal to k suppose. So here also we are using the k method. That means we have assumed each given ratio is equal to k. Now this first is equal to second is equal to third is equal to last. So equating first and last and by cross multiplication, what do we get? A is equal to k into y plus z, isn't it? So it is cross multiplied, right? So again equating second with last and by cross multiplication, what do we get? B is equal to k into z plus x. This is number 2. And again equating third with last and by cross multiplication, what do we get? C is equal to k into x plus y. So this is equation number 3. Is that clear now? So now we will use these values of A, B and C to prove this required result. That is, first ratio is equal to second ratio is equal to third ratio. So let us write down the first ratio. What is the first ratio given out here? That is, first ratio is equal to, what is the first ratio? A into B minus C divided by, it is y square minus z square. Alright? So let us put the value. So what was the value for A? It is k into y plus z, k into y plus z, right? And within second bracket, what is the value for B? K into z plus x. Then minus, what is C? K into x plus y. K into x plus y, second bracket close, whole divided by, denominator remains same. That is y square minus, it is y square minus z square. It is y square minus z square. Just, so in this case, just we are putting the values of A, B and C from 1, 2 and 3. Okay. So let us simplify the numerator now. So is equal to k into y plus z is there into. So what is common here? K is common, isn't it? So let us take it outside. K within bracket, what do we get? Z plus x. Let us write z plus x. Then minus sign is there. Minus x. Because of this minus sign, minus into plus is minus y. Is that clear? So whole divided by y square minus z square. Clear? So here x gets cancelled, you can cancel them. So is equal to, you can multiply k by k square. It is y plus z into. Now you should make it, since there is y plus z, you should make it y square minus z square. So let us take minus common here. So minus y minus z. If minus is taken common here, it becomes plus y minus into plus minus z. Whole divided by, in the denominator, it is y square minus z square. Right? So minus comes in the front, minus k square into. So what is the formula that you can use here? A plus b into a minus b. What is it? A square minus b square. So it is y square minus z square divided by, in the denominator, y square minus z square. Is that clear? So you can cancel them one by one. That means which is equal to minus k square. That means what is the value of the first ratio? That is, first ratio is equal to minus k square. Now you should simplify second ratio and third ratio. Both of them should be equal to minus k square. Then only it will be proved. Right? So now let us write down the second ratio now. Let us write down the second ratio here. What is the second ratio? Let us write down second ratio is equal to, what is it? What is the second ratio? B into c minus a divided by z square minus x square. Okay, so here also you should put the values of b, a and c. Let us put its value. So is equal to, what is b here? K into z plus x. K into z plus x within second bracket. Let us put the value for c. What is c? K into x plus y minus, what is a? K into y plus z. K into y plus z, second bracket closed. This whole divided by denominator remains same. That is z square minus x square. It is z square minus x square. Right? So let us simplify it again. And here also you should get minus k square. Okay? So is equal to k into z plus x. Right? So what is common here? K is taken common. So within bracket, what do we get? X plus y. This is your x plus y, then minus y minus z, right? Minus y, because of this minus sign, this plus becomes minus, because plus into minus is minus z. So this whole divided by, it is z square minus x square. So here you can cancel this, plus minus y gets cancels. Is equal to this k into k, you can multiply it. So it is k square into z plus x into, here also you take minus common and you write z as a first term. That is, minus is taken common, it is z minus x. This whole divided by z square minus x square. Right? So is equal to minus k square. And what is a plus b into a minus b? That is a square minus b square. You know the formula, isn't it? A plus b into a minus b is equal to a square minus b square. Divided by, it is z square minus x square. So here you can cancel it. It is divided, that is 1 by 1, which is equal to 1. So which is equal to, this is also minus k square. That is, second ratio is also minus k square. Is that understood now? So now, you should get the value of the third ratio also. So let us get the value of the third ratio now. So let us write down the third ratio. Third ratio is equal to, what is the third ratio here? C into a minus b divided by, what is there? It is x square minus y square. So here also we have to put the values of a, b and c from 1, 2 and 3 respectively, right? So what is the value for c here now? It is k into x plus y. It is k into x plus y within second bracket. What was the value for a? It is k into y plus z. It is k into y plus z minus, what is the value for b? This is a, this is b. What is b? B is k into z plus x. Z plus x, second bracket closed. This whole divided by, denominator remains same. That is x square minus y square. Okay? So again, similarly you can simplify it further. So let us simplify it. Is equal to k into x plus y. So here k is common. Within second bracket, k within bracket, what do we get? Y plus z. It is y plus z, then minus z, minus into plus, minus x. Right? Whole divided by, it is x square minus y square. It is x square minus y square. So here you can cancel, this z gets cancels. So which is equal to k into k square x plus y, and here also you take minus common. So into, this is multiplication, minus is taken common. So within bracket, what do we get? Minus into minus plus x, minus into plus minus y. Whole divided by, this is your x square minus y square. So which is equal to, now minus sign is taken outside, minus k square into, what is this? A plus b into a minus b. It is a square minus b b square. So it is x square minus y square divided by x square minus y square. So here you can cancel them. So it is 1 by 1, which is equal to 1. So what is 1 into minus k square? So it is minus k square. Is that clear? So first ratio we get minus k square. Second ratio also minus k square was there. And third ratio is also minus k square. That means we have proved first ratio is equal to second ratio is equal to third ratio. So you have to write down the answer as, hence, write down the question, a into b minus c divided by y square minus z square is equal to b into c minus a divided by z square minus x square is equal to c into a minus b whole divided by x square minus y square. So it is proved. So I think you have understood it. So you can copy it. Now we'll do the next question. Okay. So now we will do the next type of question, that is question number 12, very short answer type question, that is VSA. So this question carries, each question carries 1 mark. Okay, that is multiple choice question. You have to choose the correct answer out here. So number 1 is, number 1 is 12, number 1 is the fourth proportional of 3, 4 and 6 is A number 8, B number 10, C number 12, D number 24. Only one option is correct. So you have to choose that correct option, right? So I told you about the fourth proportional in the previous class. That is, if 4 numbers are given, that is A, B, C and D. If A, B, C, D are in proportion, then you can write A is to B is equal to C is to D. So here you have to find out the fourth proportional of 3, 4 and 6. Okay. So let us assume, let us do the solution now. Let the fourth proportional be what? X, right? So let the fourth proportional be X. So therefore 3, 4, 6, x are in proportion. This fourth proportional means these 4 numbers 3, 4, 6 are the given 3 first numbers including x are in proportion. That means what can we write? 3 is to 4 is equal to 6 is to x, right? That is, the ratio of 3 and 4 should be equal to ratio of 6 and x. So you can write it in terms of fraction. So it is 3 by 4 is equal to 6 upon x. So here x is an unknown quantity. You have to get the value for x by cross multiplication, right? So, or what do we get? That is 3x is equal to 4, 6 are what? It is 24, right? So what is the value for x now? It is 24 upon 3. 3 1 are 3, 3 8 are 24. That means x is equal to what? 8. So what is the fourth proportional now? It is 8. So fourth proportional is equal to, it is 8. So which is the correct option out here among these 4? That is number A. So number A, 8 is correct. So this is your answer. Okay. So we'll do the next question now. So now we'll do the next question, that is 12A number 2. You have to choose the correct option here also, multiple choice question type. The third proportional of 8 and 12 is what? You have to find out the third proportional of 8 and 12. That means you have to find out the third number here. So let us assume, let the third proportional be x, right? That means these are the first two given numbers, 8, 12, including x, are in proportion now. Are in proportion, right? So what can you write? Here the middle term will be repeated twice. That means ratio of 8 is to 12 is equal to this. 12 is repeated again for the second ratio. That is 12 is to x. Now here also similarly as in the previous problem, you can easily get the value for x. Now this ratio can be written in terms of fraction. That is 8 upon 12 is equal to, this is 12 upon x. Okay. So you can do cross multiplication now. That is 8x, 8 into x is 8x, then it is 12 into 12 is 144, right? So what is the value for x now? Or x is equal to, this is 144 divided by 8. So you can cancel, 8 ones are 8, 8 ones are 8, then 64, 8 8s are 64. That means this is x is equal to what? It is 18. So what is the third proportional out here? The third proportional is equal to 18. Therefore, third proportional is equal to 18. So which is the correct option here? That is C. 18 is correct. That is 18 is the correct answer. So I think you have understood it. So you can copy it. We'll do the next question now. Now we'll do the next question, that is 12A number 3. This is also multiple choice question type. You have to choose the correct options among these 4 options, that is A, B, C and D. The mean proportional of 16 and 25 is, which is the correct option? So mean proportional means you have to find out the second term. That is first and third term are given. You have to find out what? The second term. So let us write here, let the mean proportional be x. Let the mean proportional be what? X. That means this is the second term of this 16 and 25. 16 is the first term, 25 is the third term. This is your second term. Mean proportional means you have to find out this second term, right? So therefore 16 comma x comma 25 are in proportion. That means what can you write? Again 16 is to x is equal to, again x is, this second term is repeated twice, x is to 25. Is that clear? So or let us write it in terms of fraction. 16 by x is equal to x by 25. So now you do cross multiplication. That is x square is equal to x into x is, this x into x is x square is equal to 16 into 25. That is 16 multiplied by 25, right? Or now you have to take the square root on both the sides. What is square root of x square? That is x. And take the square root of the right hand side. That is root over 16 into 25. Okay? So or x is equal to, what is square root of 16? 4. What is square root of 25? It is 5. That means what is the value for x? X is equal to 5 4s are, that is 20. So what is x here? We had assumed mean proportional as x. That means x is equal to 20. So what is the required mean proportional? Therefore required mean proportional is equal to 20. Therefore required mean proportional is equal to what? It is 20. So here, which is the correct option? C. So C, 20 is correct. So C, 20 is correct. Okay. So you can copy it. So today also we did some problem. So you can revise all the problems that we did today. So your homework is the revision. You can revise it. Okay. So this much is for today. So in the next class we will do more problems on this topic, that is ratio and proportion. Okay.